Hello everyone, and good afternoon to you all. My name is Mandar, and I'm going to present on topic the modern day intelligent workflows with Azure LogicApps and cognitive services. And thank you all for joining the session in the middle of the afternoon. So, a little bit about me. Uh, those of you who don't know me, my name is Mandar Dharmadhikari. I am a technical consultant at a firm called as Chamonix IT Consulting, and we are based out of Adelaide, South Australia. We are a Microsoft uh, partner organization, and we help our clients modernize their application to Microsoft Cloud. I'm an integration and AI enthusiast, so I earn my living developing integration solutions for my clients. And in my free time, I generally write and speak about integration and artificial intelligence, mostly from Microsoft Azure perspective. Uh, I am a TechNet Wiki ninja. I have contributed lots of articles to Microsoft's TechNet Wiki, and I also have my own blog at theabodeofcode.com where I write about integrations and various Azure related development stuff. So I started blogging about GitHub Actions recently. So if you guys are interested in doing DevOps for your cloud artifacts, I would suggest you keep eye out on for my blog. I'll be posting a lot of content on GitHub Actions soon. My GitHub repository handle is Mandar Dhikari. And if you want to tweet about today's session, you can use my Twitter handle at the rate aboutofcode.com. Post session, if you guys want to connect with me, you can send me a request on LinkedIn. Sorry, I'm not on Facebook. So that's all about me. Uh, so what takeaways can we have from this session? What we can hope to learn? So that's first we'll try to understand what Azure Cognitive Services are. Well, I know it's a really big topic, but I'll just cover the basics of it. Then we'll cover the basic of Azure Logic Apps. And in my career of developing intelligent workflow or rather integration workflows for my client, I have came across various scenarios where a modern day intelligent integration was required, which was unconventional to the standard HTTP best REST APIs. So the demos that I will show here in today's session are inspired from what I did as prototypes for my clients over the last few years. And then I'll point you to some reading resources, and then we'll take some questions if you guys have. So the session, as I can say, won't be too much concept heavy. It would be light and breezy, and I'll try to cover most of the demos throughout the sessions. So the term artificial intelligence. So before we move on to cognitive services and what they are, we need to have a basic understanding of what artificial intelligence is. So artificial intelligence was first coined in 1956 by John McCarthy, who is considered as one of the founding fathers of artificial intelligence in computer world. And once it was coined in 1956, then 5 or 6 years later, uh, one of the greatest minds of computing world, Alan Turing, wrote a paper on the idea of computer systems being able to simulate the human beings and develop intelligence. So he reasoned in his paper that the computer system can be trained to play a game of chess, which was the case of some year later when a computer played a chess game with Gary Kasparov, one of the grandmasters of the chess world. So Alan Turing and these guys envisioned the artificial intelligence to be something that would enable machines to reason like human and become intelligent. And over the time, the idea initially was that the artificial intelligence can be used for good and can aid human effort of work. But over the time, thanks to Hollywood sci-fi movies, the concept got a little bit skewed, and this is what artificial intelligence was shown to us later in 1980s, 1990s, and even in the early 2000s. So if you guys have seen the Terminator movie, it's basically Arnold killing everyone and killing Terminators, saving days, and that kind of thing. So AI was always shown to us as something destructive, which was not the intention of the forefathers who coined the term artificial intelligence. So today the condition has changed a lot, because today we are exploring the options of using artificial intelligence for the good of the community. And if you can see, there are a lot many posts on LinkedIn or on even on Medium where people are talking about how they have used artificial intelligence, say with Python or other open libraries, to analyze the COVID-19 situation. So that's what the good thing about today's world is that we are not somehow referring to this skewed version of artificial intelligence. We are actually talking about artificial intelligence for good, and this is what AI on Tour aims to bring out to people, that how we can use Microsoft's cognitive services for good of the people, and we can have best business values achieved through it. So the term cognitive services has a root in the noun cognition. Cognition means the mental action or process of acquiring knowledge and understanding through thought, experience, and senses. So this is a process that we as humans do unconsciously. We are not conscious of this process whenever we are interacting with our environments or uh, any systems or even new people. We are continuously assimilating information based on their facial expressions, their addiction, their behavior, and we are analyzing it in the back of our mind and forming some important information regarding them, so that we can come back to it at a later point of time. So when this process, the term cognitive is defined as the process of cognition. So that's where the word cognitive services comes from. So that brings us to what cognitive services are. Cognitive services are the services which facilitate cognition, which in turn allows machines to learn, assimilate info, analyze it, experiment with it, and derive uh, sets of knowledge which they can use to reason when certain amount of information is fed to them at a later point of time. So that's basically the high level idea of what a cognitive service is. From Microsoft's Azure perspective, cognitive services are the APIs that Microsoft has developed, which in the backend, which masks the complex machine learning algorithms that are required in the backend to build such intelligent systems, like recognizing face, analyzing behaviors, recognizing speech patterns, detecting sentiments, so on and so forth. So if we take a look at the reasoning process and try to correlate it with what we humans do, you'll understand that the data set required to form a reasoning flow is just too huge. So for us, for mere mortal developers who are not into data sciences or who don't want to invest too much time building such common or complex machine learning algorithms, Microsoft has given us a helpful solution in terms of Microsoft's cognitive APIs. So these APIs are basically REST-based APIs, wherein you provide or push a set of data to these APIs, and they utilize the complex machine learning behaviors in the backend and give you set of results which you can use as milestones in your workflows that you want to develop based on them. So cognitive services comes in different shapes and flavors. So the first one and the most common one is the face API, wherein you sort of take the images, feed them to the Microsoft Cognitive Face API. It runs the backend algorithm on it and detects whether the image has face. It detects where the face is located inside the image. It detects the emotions on it. It detects whether person is wearing spectacles or not, they are smiling or not, whether they are male or female, and other sorts of things. Then there is computer vision API, which allows us, or rather computer systems, to generate intelligent information based on the images that are fed to it. So computer vision cognitive APIs include options like doing optical character recognition, meaning the systems can now read the text from the images, or even if it is a handwritten text or even if it is printed text. So when that image is particularly fed to computer vision API, it extracts out the text that was written on the image. So that's one aspect of it. Computer vision allows you to generate thumbnails for your images. Computer vision allows you to recognize famous personalities, famous landscapes. So I distinctly remember I built a bot 2 or 3 years back using computer vision API, where it was kind of a gaming bot wherein when you feed it an image, it analyzes it and tells you what celebrity is there in the image or what landmark is there. So that's how we can use AI for good. We can use it to engage children to understand the world around it by developing such fun game bots. Then we have one of the another important aspects. So natural language processing. So that's what we humans do when we communicate with each other. We actually know the semantics of the language and how and the grammar of the language, and that's why when two person who knows, say, English and know the structure of the language, they can easily pursue and understand what they are saying to each other. So that's what natural language processing is. So Microsoft Cognitive Services has provided LUIS, which is Language Understanding Intelligence Service, which was covered in the very first session of AI on Tour today. So it basically helps machine understand what command has been given to them or what request has been made. For example, in cases of bot, if I'm saying that I want to book tickets to, say, Mumbai, that means that my intent is that I want the tickets booked and my destination is Mumbai. So as a human, I understand what I need to do, that I need to actually go to the site and book the tickets to Mumbai. But for the machine to be able to understand it, this is where Lewis comes into picture and facilitates it. So when you feed this text that I want to book a ticket to Mumbai, that basically, when it is fed to the Lewis service, it determines that, oh yes, I want to book a ticket and I want to go to Mumbai, and this enables the machines or the software, which is a bot in this case, to do the necessary tasks. So it again provides intelligence. We have speech translation services. The greatest example of using AI for good in this field is with Mr. Stephen Hawking, who was a really great scientist of our age, and he was a completely paraplegic person, but with the speech translation, he was able to convey his feelings or what he was thinking through the machine assisted uh, conversion. So basically, the machine would read the movement of his uh, cheeks and translate it into voice. So that's again something we can do with not exactly that, but that's something that cognitive services allows us to do. We can do speech translations. We can even formulate a way of implementing what was implemented for Mr. Stephen Hawking. Then we have anomaly detection, which can be used to detect any anomaly in the data sets that we are analyzing. And the last one, well, not the last one, but another important part of cognitive services offering is using the bots, which Manoj so awesomely covered in the previous session. So all of these services, well, this is just the gist of it, but all of these services are most of them are provided as APIs by Microsoft, which basically abstracts the complex machine learning in the backend and allows us to do a lot of awesome stuff. So these sets of API can be used for good too, and we can use them to create intelligent workflows and systems. So how we do that, we'll see just in a few minutes in our demo. Then, if we, then I want to cover a bit about LogicApps. So LogicApps are the integration platform as a service offering provided by Microsoft. LogicApps are completely serverless, as the Logic App runtime engine is completely abstracted from us developers, and it is maintained by Microsoft internally. Uh, this allows us to automate workflows and orchestrate business processes, both of which we'll see in the demo. And these integrations can range from business to business, APIs to APIs, applications to application, the complex enterprise level integration spanning multiple protocols like SFTP, even WCF, REST APIs, HL7, so on and so forth. So Logic App has inbuilt abilities to support the enterprise level integrations. Logic Apps are really easy to develop because they are based on designer first approach of development, which allows us to create workflows on the Azure portal or in the Visual Studio by dragging and dropping and adding connectors and configuring it. So it's basically very less to no code based workflows wherein you can set up a business process, automate it in just a few hours or few minutes, depending upon your familiarity with the Logic apps. There are 300 plus inbuilt connectors provided by Microsoft Azure, and they integrate with plethora of systems like Microsoft 365, Slack. It integrates with Jira. It integrates with GitHub, Bitbucket. It integrates with ServiceNow. It integrates with all the cognitive APIs that we just discussed previously. So there are a lot of inbuilt connectors. All you need to do is just configure few keys and few steps, and you are good to go. And it just allows you to integrate with those systems. And the main advantage of Logic Apps is that it works with pay-as-you-go structure. So you only pay for what you use. Meaning, if you have executed your workflow only 3 times, then based on the billing model of the actions and the triggers, you only pay for those three runs of the workflow. There is no upfront cost for running the workflows in cloud, like you need to pay X amount of money so that you can run the Logic apps on this platform. No, that's not the case. So you just need to pay for only what you use. So that's one of the greatest advantages of using Logic apps. So this slides breaks it down into why use Logic apps from two different perspectives. On the left hand side, we have the perspective from the mind of business owners. On the right, we have the perspective of a developer. So from a businessman's perspective, serverless integration means that they are not responsible for hosting the workflows and maintaining the infrastructure in their own data center. That responsibility is abstracted away to someone else. So what that means is you don't have to pay much, or rather you don't have to pay to build those huge data centers, which basically involves cost of electricity, cost of cooling, cost of someone uh, looking out for them. So that cost is basically reduced when you have a serverless piece of code in your enterprise. Logic Apps allows us to easily connect legacy systems to the new cutting edge systems. For example, you can connect SOAP based services, which are really a thing of a past now. You can connect them to new REST based APIs or even the new ERP systems, SAP, normal REST APIs, SFTP, so on and so forth. So it allows us to connect legacy system to other cutting edge systems. And since Logic apps are really easy to develop, it reduces the time to release them to the consumers. that really boosts the revenue, and that's why it's one of the things from a businessman's perspective why LogicApps are good. And since it's integration platform as a service, as I mentioned earlier, you don't have to host your workflows anywhere in your data center. That basically reduces your operational cost. And you pay only for what you use. Again, from a cost perspective, businessman is happy. So what makes LogicApps appealing to developers? LogicApps are easy to design and you can do it using Azure Portal or Visual Studio. Azure LogicApps can be completely templatized, meaning that they can be deployed using the Azure Resource Manager template. And you can set up CI/CD pipeline for it. You can use PowerShell script. You can use Azure CLI to deploy it, or even you can use the REST references to deploy it. As I said previously, there are 300 plus out of box connectors available, so you don't have to think too much about integrating with different systems. It's just few clicks and you're up and running. So developer is always happy because they don't have to write too much code. Because if you have to write too much code, then you have to write tests for unit tests for it, integration tests for it, and then it keeps on growing. So this ease makes a developer happy. And in case if you don't have any connector that's not available out of the box, you can create custom connectors for it. So that's make the developer happy. So that was it from the theory perspective. Now I'll move on to the demos. So before we go into each of the demo in detail, what I will do is I'll explain. Sorry, someone wanted to ask a question? So what I will do is I'll explain a short story about the demo and then we'll take a look at the architecture. So illegal parking workflow. Well, this is one of the important scenarios where we can use machine learning in combination with the systems to handle how illegal parkings are managed. For example, let's for a moment assume that we are police officers and we are on duty and we see that someone has parked their vehicle illegally at a particular place. And we take a picture of their vehicle, we write a ticket for them, which we call challan in India. We give them the challan and we upload these images onto our system or the police database so that we can refer to it, or even the driver can challenge the challan given to them saying that yes, no, that was not my fault, it was not a illegal parking, so on and so forth. So in that case, sometimes it is a scenario, it can be a scenario that when the pictures are clicked, there can be human faces inside the image. And from a legal perspective, sometimes it can open up the department to lawsuits. So this is where the intelligent workflows come into picture. So what we do is that when we click an image, we feed it to our system. Our system first checks if there are any faces detected inside the image that was taken by the police officer. If there are, then the system blurs those faces and then saves that copy. So at a particular time when the copy is propagated inside a system, all the faces that are taken in the taken picture they are always blurred. So this is one of the scenarios that I had to implement for one of my clients few years back. So the architecture for this intelligent workflow looks something like this. So we have a storage account where an app or a mobile phone uploads the images. So that's how the system gets triggered. So the upload triggers an event, which in turn triggers a logic app. So the logic app gets the URL of the blob that is uploaded to this uploaded images container, feeds it to the face API. Face API detects whether there are faces inside the image that is taken. If there are faces, the next step is the logic app calls the Azure function, which in turn calls the library which draws a blur over the face of the person. The area where the library draws the face blur is dependent upon what is detected by the face API. So I'll show you how that works. And once the Azure function blurs the face, the logic app writes that particular image into a processed images container, and that contain and the this new processed image is what is fed to the other downstream systems. So this is one of the examples of intelligent workflows. So I'll show you how that this one works in action. So let's move to Chrome. Give me a second. I'll go to the resource group. Okay. Okay. So our Azure, before I show you the Azure Logic app, this is uh, the blob storage account. We have two containers here: uploads, where the mobile app or the police officers upload the images, and the images, after they are processed, they are moved into this so that the downstream systems can pick them up. So if we take a look at the logic app, the logic app is basically triggered when there is an image or whether a blob is uploaded to the storage account. So it says that when the storage account is this, which is image source 101, which is the account that I just showed you, and it says that I only want to react to the blob created events, and only to those which are uploaded inside the uploads container. So what it does is when a blob is uploaded, a webhook triggers this logic app. The logic app then reads the URL from the incoming event, sends it to the face API, and once we get a response back, all it does is it sends the image to a Azure function, and basically, and once the image is processed, it creates a blob inside the processed image, and the original blob is then deleted at a later point of time using a backend workflow. So to see this in action, what I will do is I'll go to the uploads folder, and let me show you the test data that I have for this. So let's say now again, as this is something I developed for a client, I cannot actually show you the original images that were used. So I'll use some dummy data. So this person, or I'll use this one as a test photo. So as you can see inside this photo, let's assume that it was clicked by a police officer of this particular guy, Mr. Steve McQueen, driving a vehicle, and he was standing in a no parking zone. So they have clicked the image. Now what they do is they upload somehow to the blob. Now that there can be many mechanisms for that, being a mobile app or anything. So let's just upload it here. So as you can see, it's uploading the image. Now if we go to the portal, if we go to the quick overview, we can see that a flow should be triggered here. So we see that a flow is running at this point of time. So we can see that the flow ran, it detected the face. So the output, give me a sec. So the output is that it detected the face, and it detected details like the face rectangle pertaining to the coordinates where it was detected from top, left, and what the width of the face was and the height of the face was. Then it detects the details, even the minute details like the pupils of the person, their coordinates. Then It detects whether they are wearing spectacles or not. So it can detect a lot of things in it. We just are using the face coordinates. And once that is done, I hope this workflow should be finished. It basically gets the details from the event for the blob, adds the events from what we detected from the face API, and it basically creates a message, JSON message, which we feed to the Azure function. So we pass the URL of the blob that was uploaded and the face rectangle coordinates that were detected by the face API. And the Azure function basically has blurred the image, blurred the face, and it returns back the base64 string for that particular image, and we create a blob using the blob connector. So if we check, so this shows that the workflow ran successfully. Now if we check the processed image, it should create a blob with the same name. So it just created it. Let's try opening it. And as you can see, it has successfully blurred the face. So this is one of the ways in which we can build an intelligent workflow, which really saves a lot of money if you think about it from a business perspective. Because if somebody sues you over violation of privacy because their face was somewhere else, somewhere they did not want it to be, then basically you end up with a lot of financial hardship. So this workflow prevents that and it blurs out all the faces. So that's it. That stops you from getting sued. And even if there are or faces detected in images, you can still have some manual intervention at a later point of time before it is actually passed on to the consumers. So that's one way or one intelligent workflow that I wanted to show you today. Let's move back to the presentation for a moment. So the next one is again a GitHub issue creator. So this is again something we implemented internally for one of our clients. So the story behind it is that the let's say what a hypothetical story about this is that let's say the client or we as an organization have thousands of repositories with us, and there are thousands of consumers of those repositories. Some of them are public, some of them are internal, and all of these repositories are hosted on GitHub. Now we have, while writing the swaggers for our APIs or writing the documentation for our repositories, we have stated that if you have any issues, just shoot us a mail at this particular mail ID and we'll take a look at it. So what happens in the backend is when a developer faces an issue, they send out a mail to that support mailbox saying that yes, I'm facing an issue with this and I want to get it resolved. So that basically translates to that we as internally should create an issue on that GitHub repository and let someone from the development or admin team know that an issue has been created so that someone can actually look at it. So that's a happy flow. Now, if there is someone with a wicked mind, they can just spam the mail support mailbox with invalid or stupid things. That's where the intelligence come into picture. Is that when a mail arrives at the support mailbox, we basically process it using the natural language processing, and we try to understand whether the user really wants to create an issue or not. If that is the case, then we go ahead and create an issue on that particular repository, else we just scrap the mail. So the architecture for that particular flow can be is that a developer sends a mail to the support mailbox that triggers a logic app. Logic app then sends the body of the mail that was received, it sends it to the language understanding intelligence service where we have developed a model which, when trained, understands whether the user wants to create an issue or not. If it says that yes, the user wants to create an issue, then the logic app actually goes to the GitHub, creates an issue with what the details were shared by the person. And at the same time, once the issue is created, it triggers a mail or webhook, which internally triggers or puts the message onto the Slack channel, notifying the developer or the administrator who is looking after all these repositories that yes, there is an issue created on a particular repository. So that's the high level architecture. Let's see this demo in action. So I'll just move back to Azure portal again. Let me go ahead and go to get issue creator. That should give us the Azure function, sorry, Azure Logic app. So before we move onto that, there is this Lewis app that I created. So if you take a look at build, all I have here is one intent, that is create issue. And I have fed various examples to it. For example, the code is buggy. I want to raise an issue on the repository. Code is not working. Documents are not clear enough. So on and so forth. So these kind of things, and then I basically train the app, and when I pass a utterance to this, it basically determines that whether my intent is to create an issue or not. So for example, let's just test it out. Code is not correct. I'm facing facing problems. Let's hope that it detects. Right, so it detected with 0.988 value that the utterance that this particular string means that the issuer of that command wants to create an issue on the GitHub or issue somewhere else. So it detected this intent. So that's what I'm leveraging inside my Logic app as a uh, piece of intelligence based on which I will do my decision making. So if we go to the Logic app, you can see that my Logic app is getting triggered when a new mail arrives in my mailbox. I then pass on the body of that from that particular mail onto this issue detection app, which is basically this app that I created in Lewis. And what I'm telling it is that the version of the app is 0.1, and what I want is that the desired intent in this step is that create issue, meaning when I pass a string to this Lewis app, I'm checking whether the desired intent here is create issue or not. Well, that returns me a true or false value for is intent. So it basically tells me that if the desired intent is true, meaning if the intent of the user is to create an issue, the workflow goes ahead and creates an issue on the repository name. So the document says that the repository name needs to be specified in the subject. Then we provide the title and we provide the issue details. And once that is done, we send a HTTP webhook request to one of our Slack channels. So it's as simple as that. So what I will do now is I'll show you this in action. So I'm going to send, let's see if I have it somewhere in the drafts. Yeah. So I have a API on my GitHub. So before I do this, let me show you that API. So this API is called as test Pokemon API. So it's basically an API which tests the public Pokemon API, and it runs some GitHub actions on it. So this is something I wrote for another one of my talks, but this should do for the time being. So as you can see, there are currently no issues on this. What I'm going to do is that I'm going to send a mail saying, let me just say forward. Did the subject. Let's say I just provide the repository name and it just says that I'm facing a problem while working with the repository test Pokemon API. The tests are incorrect, right? And I just add my mailbox ID for that, and that's it. I just send it. Now the Logic app in the backend is polling this particular mailbox every 3 minutes. So to speed up the testing, what I will do is, let's see if it has triggered it first. 518, not yet. So let me just run this trigger manually, and will it pick it up? Not yet. Yeah, so we have running. So now you can see that there is a message that has popped up in the Slack. But at the same time, let's go to the repository. I'll just refresh the page, and you can see that it has created an issue with these details, and at the same time it has notified me as an administrator on my Slack channel. It says that a new issue has been opened on repository this, and it provides you the list, then the person who reported the issue, when it was reported, and the issue details. So this is another of the intelligent workflows that we, or rather I have developed internally for one of my clients. I'll quickly show you one more, and that one is the one I actually showed in a previous session as well. So this one is Intelligent Feedback Analyzer. It's a common demo that is being overdone over a period of time over the use of Text Analytics API. So the story behind this goes as, suppose you are a hotel management or you are a big hotel uh, who is serving a lot of customers across various zip codes over India. And what you want to do is, whenever you introduce a new dish into your restaurant, you want people to give feedback to you when they are paying their bill. So you have developed the app, and that app basically calls a REST API, provides it details like the name, then the dish name, then the zip code where it was ordered, and the feedback about that dish. Now, the plan of the restaurant manager is to analyze the feedback about that dish and whether they should make that dish permanent on the menu or not. For this, they have developed the system. So, barring the app which sends out the details, the architecture looks something like this. There is a logic app which is triggered on, basically it's a HTTP triggered logic app wherein you pass the JSON message. Whatever details we get into the JSON, it reads the feedback, passes it on to Text Analytics API. Text Analytics API detects the sentiment, gives us a score between 0 to 1, showing the a degree of positivity or negativity. So the higher the value, the positive the message, and vice versa. And once that is done, the logic app basically dumps the entire JSON message plus the detected sentiment into the Cosmos DB, so that at a later point of time, another process can pick it up and create graphic, use this data to create reports using Power BI or any reporting tool. So that's another simple scenario. So the way it looks in Azure portal is that we have, this one should be short. So we have, sorry, I forgot to tag the logic app. So we have this analyze customer feedback logic app. If you take a look at the logic app, it's really simple. It basically accepts details like the dish ordered, the feedback, uh, the name of the consumer, the zip code. The zip code is basically used to create partitions in Azure Cosmos DB. So based on the value in the feedback field, it sends the feedback details to the Text Analytics API. Text Analytics API returns the response, and basically we are creating this document which we will insert into the Azure Cosmos DB. So it inserts the dish ordered, the feedback, the name, and the sentiment that was that is generated based on the value of the feedback provided, and the zip code. which is used as a partition key inside the Cosmos DB, and that's basically it. And the last action creates or updates that particular document in the Azure Cosmos DB. So the Cosmos DB looks like this. So if we go head on to the Data Explorer, you can see that we have a database by the ID of hotel management, and inside that I have a container specifically to store feedbacks. These feedbacks are categorized across postcodes so that at a later point of time we can analyze how each locality feels about that particular dish, and how positive or how negative the feedback was. So at this point we don't have anything in this. So let's just feed it some data. So I have a sample message here with my name. And then we have details like the dish ordered, basically pasta. Feedback is it's an awesome dish. So if we just send it and go to Azure portal again, refresh this again, hopefully it will show up. Yep. So there is this one that has come here. It says that the dish ordered was pasta. Feedback was awesome dish submitted by me. And you can see that the sentiment is 0.9977, which means it's a very strong feedback. Now let's try something else. I'll say one of my favorite characters. Keep it as it is. Let's send this. And hopefully it should give us a negative sentiment. So let me refresh this and it should have another one. Yeah. So you can see that based on this word, the dish was dismal. It created a very, very low score for sentiment. And once we collect the data over a period of time, let's say 1 month after rolling the dish, we can analyze how the public feels about it, and we can do this analysis bit for any other workflow, like analyzing the tweets done by our PM Mr. Modi, or the tweets done by World or WHO on the COVID-19 scenario. What's the general sentiment of people? We can analyze huge chunks of data easily, and then create a reporting based on the sentiments. And as you can see that the Logic app basically has 4 or 5 different steps, and there is very less to no code involved in it. So once you have a little bit of hang about Logic Apps, it's really easy to do it. And since it's all done using an integration platform as a service, it can scale according to the load that is generated on the system. So everyone is happy. So I'll move back to my presentation. So that was all. The reading resources for this is, I would encourage you to go to the cognitive services landing page as well as LogicApps landing page. But if you have any specific questions in regarding these or how to get started, just ping me on LinkedIn and I'll be happy to help you out. And that being said, that's it. That was all that I wanted to convey today. I hope you liked this session. And if you have any questions, I'll take them now. Thank you.